All right, good stuff. We got that going. Nice, nice. All right, should be good to go. Nice. See if we're doing okay. Nice little hello message. Yeah, we're doing all right. Nice. All right, hello, hello, hello. Okay, hopefully this will work out better. A few minutes for people to get here. Okay. We got a few more people coming in. Good, good. Got that. Alrighty. Hopefully everybody's doing well today. I hope everybody's doing okay. How's everybody this morning? Hey, hey Chase. When will our Unit 2 test start? Yeah, I'll have to. I think we're. I forgot. We didn't finish. We haven't finished Chapter 3 yet, Chase. I don't think so. So we're not quite there yet. Once we finish Chapter 3, then I'll have then we'll have our Unit 3 test there. Good morning, Alyssa. How are you? So I'll always make the announcement, by the way, um, when I am giving a test a week before the test will be due. So I'm guessing like in either this week or next week, I'm going to make an announcement. Just depends on how fast we go. I'm just going to ask this question. Can everybody hear me okay? Um, apparently I had mic issues last time, so I'm just making sure that mic issues has been sorted out somehow. Okay, so I sound clear and everything? Okay. All right, cool, cool. All right, as long as I sound clear and you guys can understand me, because apparently I was doing the robot yesterday, and then I had to do some things here. So Hopefully today I made a few changes to the stream. I'm just Sorry about last week. I was kind of experimenting around a little bit, um, just to try and get the stream a little bit more consistent. So I figured some additional stuff out, and hopefully we should go on without too many worries from here on out. Okay, so that's the goal there, and we're gonna make this happen. I've been working hard behind the scenes. All right. Oh, okay. It's 9:32 here, so let's go ahead and let's get going. Okay, let's get started today. Welcome back to Tuesday. Hopefully, you have a nice weekend. All right, so today we're going to do probably our most important day here today. Today is going to be just chock full of examples, a lot and a lot of examples here. But for us to kind of set that up, we're going to continue where we left off last week, which was talking about the least common multiple. So we did talk about the least common multiple. We did some examples in regards to that. But the question really becomes is what we are going to specifically be using the least common multiple for. And that is going to lead into addition and subtraction of fractions, which for a lot of people tends to be a lot more difficult. But let's at least talk about how we can attack these kind of problems. And we're going to look at it from a couple perspectives. We'll look at it from the basic kind of addition, subtraction of, in this case, by the way, unlike fractions. And we'll also do a mixed numbers also as well of unlike fractions. So we're going to look at just two different looks at adding and subtracting, and we'll put it all together. But the linchpin of all this is going to be the least common multiple that we talked about here last time. So I want you to take a look at what we have up here. It says we talked about how to find the LCM, but in this case, this example here is going to highlight exactly what we're going to be doing. All right, and I want to kind of discuss this part here in particular. It says write a fraction with the indicated denominator. So it says write the fraction 2/3 with a denominator of 15. Okay, so let's take a look and see how we can do that. Okay, write 2/3 with a denominator of 15. So let's put in 2/3 just as a fraction up here. So put 2/3, and that's equal to something over 15. So we don't know what that something is. You know, it's something over 15. That's what we want to find out. Now here's the thing. Let's talk about what, you know, we want to magically change 2/3 to something over 15. Now, let's take a look down here. On the bottom here, we have 3. And somehow we want to change it to 15. Now, the way we're going to do that here is let's just put this up here for now. Okay, so we'll fill in the blank here in just a second. But let's talk about the big key here that we want to discuss. All right, and what's going to be pretty repetitive in a lot of these problems. So the big key here is going to be we want to find a number to specifically multiply to change the denominator to what we want, okay? So we'll talk about the second key here in just a second because there'll be a second key. All right. So let's take a good look here at this guy. We have 2/3 equals something over 15. So let's answer here. Since we have to multiply, what times 3 equals 15? So what times 3 equals 15? All right, 5. That's correct. Okay, so let's rewrite this here for just a moment. All right, very nice. So here we're going to multiply this by 5. Okay, so I'm going to put that in parentheses here just to showcase that, yeah, we multiply that denominator here by 5, and then somehow, 3 times 5, we know for a fact, is 15. Okay, but this will lead us to our second point that we want to talk about. So our second key here that we need to discuss. So although we change the denominator to the number that we want, the second key here is we also multiply the numerator by the same number we multiplied the denominator by. So if I multiply by 5 here on the denominator, I got to do the same thing here in the numerator. So it's not a one-way street. I got to do the same exact thing. So now I just multiply 2 times 5 here, and I get 10. Okay. So for us to put this together here, we follow those two keys, and specifically, to get our number that we want here, we want 10 over 15. That's what we get. Now, we're not reducing anything down, okay? So do make a note, we're not reducing anything down. We're not going backwards here. We're just rewriting the fraction in terms of what we want here for our denominator. This will prove to be important for our addition and subtraction. So put one note here, do not go backwards and reduce again. That seems to be a common mistake there, so for whatever reason. So make sure you make sure you don't do that there. Oh, let's put that over here. Okay, now let's talk about the key about why I'm kind of stressing this particular example a lot. Okay, when it comes to adding, subtracting fractions. Thank you, Diego. You have a great day too, my friend. I'm gonna see you tomorrow. All right. Um, let's talk about the big key here. So the big key here is what's the big key? So amongst these first two keys, there's of course multiplying denominator and then multiplying the numerator. But the big key here between both of those is going to be just one thing, and that is going to be the word balance. Balance is the number one thing in algebra. If you're going to understand how algebra works, even in pre-algebra, if you're going to understand how things work, whether that be with variables or numbers or whatever, balance is the most important thing that you can learn. It's one simple word, and it makes your life significantly easier, especially when talking about adding and subtracting fractions. If you've ever had a hard time with it, well, balance is definitely going to be the word of the day for pretty much every example that we're going to be doing. Okay, so you'll notice that we're going to employ this over and over and over again. But like I said, we're trying to make the process significantly easier, so we're not going to try, we're essentially just trying to make it, we're trying to be as lazy as possible, okay? You know, lazy way is the best way. That's what we do here. So, with the laziest way being the best way, uh, then, that's basically how we're just trying to approach this. All right, seems fair. Okay, now let's look at another example here really quick. So let's look at this one here. It says 7 over 6 equals something over 42. So let's look at that one, and we'll do that one really quick. Equals some blank here over 42. Okay, so notice here, I want to change this 6 here to 42. So what should I multiply 6 by to get 42? Seven. That's correct. Good. Now, if I multiply by 7 on the denominator, or on the bottom, what should I do next? Okay, very good. That's right, Yvonne. So if I multiplied the denominator by 7, I got to multiply the numerator by 7 because I have to balance it out. What I do on one side is what I got to do on the other side. In this case, this happens to be the bottom and the top. And that's correct, Yvonne. Spot on here. 7 times 7 indeed is going to be 49. And that is the correct answer for what they're looking for here. Okay. So I just wanted to point out here, you see that the balance, that's what they ask us to do. Of course, you're like, oh, well, that was what they asked us to do. But you can see, like, hey, you'll see me write this over and over again. You'll see me write this as times 7, and then I got to do the same thing here, times another 7, or whatever number that we happen to multiply that denominator by to get what we want. And then we do the same thing for the numerator. All right, questions so far about that? All right, we'll move forward here. That's perfectly fine. No, all right. Let's move forward here. Okay, so now that we talked about that example, and that was, again, a very specific example here, we're now going to talk about how to add and subtract unlike fractions. So now let's put the pieces together. This is going to put the first section and the last section here we just did with the least common multiple here together, and we're going to see exactly how we can attack these type of problems here. Sure, Hannah, that's not a problem. We can certainly do that. Absolutely. All right. No problem, Hannah. Of course. All right. So let's go over section 3.3, adding and subtracting of unlike fractions. Now, in this case here, what are unlike fractions? Well, let's just first define that really quick. So unlike fractions here specifically, again, are uh, fractions that have different denominators. Okay, so the denominators, if we're adding and subtracting those fractions, be like, okay, cool. But they have different denominators and we got to add or subtract them together. All right, fine. Okay, now let's take a look at a couple of these problems here. We'll talk about the steps. There are steps to this, of course. But let's discuss at least how to approach this one step at a time, okay? So we're going to start with this 2/3 plus 1/9, okay? Let's add those two together. And we're going to go over slow here just to kind of understand each step and how it works. Even in a problem like this, that's still important. Okay, so let's do that right now. Oh, I don't mean to do that. Okay, I'm going to do this. There we go. All right. So here's our problem. Our problem here is to take 2/3 plus 1/9. All right. Okay, so we'll take it one step at a time. We'll see what we get. So step number 1 here. And let's put this here. So step 1. Okay, so step 1 here into adding or subtracting, and this applies for both, add, addition, or subtraction, doesn't matter which, is we are going to first find the, what we're going to say, the common denominator between all of the fractions. Okay, so we're going to find the common denominator, which you will see. I will label that as, where is the cursor here? There it is. Well, I'll label that as CD for common denominator, so you'll see me write that fairly often because I just don't want to write that over and over again. So we're going to find the common denominator between all the fractions. Now, specifically, what is the common denominator? So the common denominator here, just for definition's sake, is equal to the common multiple here between least common multiple here between all the denominators. Okay. Okay. So let's talk about that step right now, okay? Because we can't proceed to do anything else in the problem without doing step one first. So if we were to find the common denominator, we have two numbers here. We got 3 and 9, okay? So can anybody tell me what would be the common denominator here between 3 and 9? What's the common denominator that we get here? Say 3. Okay, so I got a couple people say 3. Anybody else? Just 3? Okay, well, let's talk about this one more time here. Okay, maybe I'm gonna put that down there. Sounds like a plan. All right, let's talk about this. Let's talk about this, ladies and gentlemen. This is the most important part here, so we're gonna go ahead and discuss this right now. Okay, so let's recall back to what we talked about last week. When we talked about the common multiple between the numbers, right? We always start at the largest denominator, okay? We always start at the largest denominator. So, the second note here, note 2, the common denominator is always the largest denominator or a multiple of it. Or I should say, or higher. Let me just say or higher. Okay. So remember, we talked about these two things last time. Okay. So we always start at the largest denominator, which in this case happens to be 9. And we see that if the other denominators can divide that largest denominator. Okay, so it's always going to be 9, or at least it'll always be 9 in this case, or at least something that is going to be divisible, going to be a multiple of 9. So it could be 9, it could be 18, it could be 27, it could be 36, whatever the case may be. So that's the plan there in this case. So we see if we start at 9, well, 3 divides 9, and 9 obviously divides 9. So our answer, our common denominator here, is going to be 9. That's going to be our answer for our common denominator. Okay? And before we move forward here, are there any questions about that? Okay, when we talked about least common multiple, we say, okay, hey, well, that's going to be our common denominator there. So we're going to employ that same technique as last week. Okay. If there are no questions, I'm going to move on, okay? Again, I know this stuff is confusing, so if you have questions along the way, again, feel free to ask, okay? It's very important. This concept here tends to be a little tougher than the others. Okay, now let's talk about the next part here, step number 2. Okay, so what is step 2? Well, now that we know that the common denominator has to be 9, and that's fair, all right? Next, we want to multiply each denominator, but actually, well, each denominator, we'll go with each denominator, by a number so we match the common denominator. Okay? And then, of course, that's what we want to do here. So then multiply the numerator of each respective fraction by each respective number to balance. Okay? Okay, so that is going to be step number 2. So let's take a look here on how step 2 looks. Okay, so in this case, we want a common denominator of 9. Okay, so we want a common denominator of 9. So let's take a look here. I have a 3 down here, but I want to multiply that by a number to make it 9. So what should I do here? What should I multiply that 3 to make a 9? 3. That's correct. So I'm going to multiply by 3 here in this case. All right, spot on. But also, if I multiply by 3 down here, I also have to multiply by that same respective number here in the numerator. I have to multiply that by 3. Okay. Now in this case here, for the second fraction, I already have 9 in my denominator, so I don't need to change it at all. I don't need to multiply by anything because I already have the number that I'm looking for, which happens to be 9. So I can leave it alone and it'll be just fine. Okay, so now what I have here is, let's take a look at what we have here. We have 2 times 3, which is 6, over 9, plus, in this case here, 1 over 9. So this is what we have here for step 2. Okay. So that's all step 2 is, just kind of rewriting the problem with our common denominator that we found in step 1. Okay? So that's that right there. Okay. Got one more step to go. Okay, so let's talk about this last step here. So step 3. So step 3 is to either, again, add or subtract the numerators, okay, straight across, and keep the denominator the same. Reduce if necessary. However, I want to make a note here. Reduce if necessary after you add and subtract. Okay, so not before, but after. All right. So let's see what we have here in this case. In this case, we have 6/9 plus 1/9. That's what we got. So all we're doing here is what we learned in the first section. We now have it in terms of like fractions because they both have the same denominator. So we just go ahead and add straight across here in this case, but we keep that denominator the same. So we have 6 plus 1, which is 7. You put that over 9, just like so. So 7 over 9, and that will be our final answer for this problem here. In this case. Okay, and that's it. Okay, any questions so far about that? No? Okay, that's perfectly fine. Okay, now that we have those steps ready and available for us, all right, let's try some other problems here. Okay, so we're going to try out some basic problems here to start, and then the next section talks about mixed numbers and whatnot, so we're going to discuss that as well. All right, so let's look at some other problems here. Okay, so I'll have you guys kind of guide me, all right, through a couple of these. So let's look at let's look at this one here. 3/5 plus 3 over 10. So let's write that one down. 3/5 plus 3 over 10. Okay. All right. So let's go through the steps here. All right. So can anybody tell me what's our common denominator here between 3/5 and 3/10? What's going to be our common denominator? Okay, very good. The answer is 10. So remember, you're always starting from the largest number. So we start at 10. Does 5 divide 10? Yes, it does. 10 obviously divides itself, no problem. But 5 also divides 10. So that's going to be our common multiple between 5 and 10. Um, that will fit the job. Okay. All right. So that's the first part done. Well, we need to change 5 to 10 in this first fraction. All right. So what should we multiply by there? Okay, good. Want to multiply by 2. But what else do we have to do with multiplying by 2? Okay, right. We also have to multiply the top by 2 as well. So let's do there. Exactly. Now the second fraction, we're going to leave it alone because we already have the common denominator of 10 here in this problem. Okay, so now let's take a look at what we have here. We have 3 times 2, that's going to be 6 over 10, plus the same 3 over 10 that we haven't touched. And now we just add those straight across. Okay, add the numerators here. We'll put that over 10. And then that's going to equal 9 over 10, which is our final answer. Okay. All right, any questions about that? Hopefully that wasn't too bad. No? Okay, that's perfectly fine. All right, let's go over some other problems here. All right, here we go. Let's try that. That's a good problem here. So let's try this one here as well. 5/8 plus 1/3. Okay. Let's try that as our next problem. 5/8 plus 1/3. Okay. 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 And before we start here, let's look at this. All right. So first things first here. I'll put this over here. First things first here. What is the common denominator between 8 and 3? Want to find that common denominator here between 8 and 3. What is that going to be? 24. That's correct. 24 is correct. Okay, now let's go through the thought process about how to find 24, okay? Let's talk about how we could do that. So again, if we're trying to find the common denominator here between 8 and 3, we start at the largest number here. So you start at 8. Now, you ask yourself, does 3 divide 8? And the answer is no. 3 does not divide 8 cleanly. So we have to go to the next multiple of 8. Thank you, Josh, for the follow. Appreciate that. Which is going to be 16. So we just the next multiple of 8 here is 16. So does 3 divide 16? Well, the answer is no. 3 does not divide 16. So we go to the next one up. We go to 24. Say, does 3 divide 24? Well, yes, it does. So that's going to be our winner here. Our winner here is going to be our common denominator between 3 and 8, which is 24. All right, so that's, again, very important here. Hey, Rohan, how are you, my dude? Hope you are well. Okay, so we want a denominator of 24. So in this case, we have 5 over 8. Well, we need to multiply 8 by something to get 24. What should that be? What should we multiply 8 by? I am doing very well, thank you. What do we need to multiply 8 by? 3. That's correct. Okay, good job, Ola. All right, so we multiply the denominator by 3, but also we have to multiply the numerator here by 3. Remember, everything in algebra is a balance. So we're always going to think in those terms. Always balance, balance, and more balance. Now, unfortunately for us, we don't, unlike the last two examples, we don't have 24 in this second fraction, but we got to make it 24. So we got 3 in our denominator. So we need to multiply it by something here. What should I multiply 3 by to get 24? What times 3 is equal to 24? 8. That's right. So we're going to multiply by 8 on both the numerator and denominator here, because we had to multiply 8 in the denominator. Why am I changing the next fraction? Because I need both of the denominators to be exactly the same. So if you see here, Yvonne, the last example was we got both denominators here being 10, right? Well, I needed that to happen because I'm not allowed. The thing is, remember, I'm not allowed to add or subtract the numerators together unless they both have the same denominator. So unless they're in like fractions, I cannot add straight across. I'm not allowed to do that. So that's the thing. Let's add that as a note though, because that's a very good question. So let's do that. Okay, so note you must have same denominator for all of the fractions before adding or subtracting straight across. Okay, this is always going to be true. If you don't, too bad, so sad. You're not allowed to do that. Okay. So I'd want to point that out there to you because that's a very good question. And that confuses people. It's like, well, you didn't do it the first two examples. You said, okay, that's fair. But remember, the common denominator here is really what dictates what we're going to be doing here in the problem. Okay. All right. Okay. Any other questions before we move on? Oh yeah, we're definitely doing more. Um, we're definitely gonna do more. Trust me. No, trust me. We're definitely doing more. Well, let's go ahead and finish this problem off here. So we get 15 over 24 plus 8 over 24, and that equals 15 plus 8 over 24. So we just add those tops together, and so here we get 23 over 24. Oh, yeah, that's true. I was going to put it over the weekend, and then I'll tell you what happened here, Jonathan. True facts. So I was going to put it over the weekend because I was spend all day Sunday to do it. And so I took a hike out to Indiana with a group of friends of mine, and then basically my back and my legs felt like jelly, and it felt pretty awful. I felt really awful yesterday. Like I was in, or not Sunday, I should say, not yesterday, Sunday. Sunday I was in like really bad shape. Like I could barely move, and I was walking like super slow. Like I was in a lot of pain on Sunday, to be perfectly honest. So I do apologize about that because it was on my. I did tell you it was going to be on my priority list, but I didn't get around to doing that. So I'm gonna get around to doing that actually today, because of the break in between. So I'll be doing that there. So that's on me. That's on me there. My friend made me walk 8 miles though. Oh, that was brutal. Very brutal. All right. That's the truth, Jonathan. I'm just be perfectly honest with you. So that, like I said, that's on me. I apologize about that. Okay, so 23 over 24 is going to be our answer for that. All right. Okay. Any questions about that? Okay. Let's do another problem here. All right. So let me go ahead and erase this out here. Okay. All right. let's look at the next problem here. All right. Yeah, 3 is. Yeah, that's pretty good. Okay. So let's have you guys give this a try. Okay. All right. So let's give a. I'm going to give you guys a minute. All right, to go ahead and give this problem a try. All right, and then we'll go through this kind of together here once you give it a shot. So let's take a minute or two, try this problem out, and see what we get. When you have your answer there, go ahead and put that in the chat. Okay, well, I got that. Do both fractions need to be multiplied by the same number? Oh, okay. That's a very good question, J Dragon. So the answer is it depends on what you need to multiply. First of all, you need to determine your common denominator there, J Dragon. Then they don't need to be multiplied by the same number. So if you're saying, oh, this is like, this is just an example. If this multiplies by 2, then the other one multiplies by 2, then the answer is no, okay? That does not happen. You need to make sure that both denominators here match your common denominator. So again, this is, as you saw in the last example there, J Dragon, you can multiply the first one by one number, it could be, 2, 3, 4, whatever. You could multiply this one by another number, it could be 5, 6, 7, 8, whatever. So they don't have to be necessarily the same number. Um, you just have to multiply the top and the bottom there by the same number, though. That part is true, but not both fractions by the same number necessarily. So I hope that answers that question. No problem. Let's take another minute here. All right, any other answers here? Okay, I agree that's the common denominator. So, fully agree with you there, Erickson. Absolutely. Now, don't forget, though, got to have our final answer with that common denominator there of 24. So that'll give a good head start to some people that weren't sure. Okay. All right. It's okay if you haven't gotten it. That's just fine. We'll go through this problem carefully, though. Okay, so as Erickson pointed out, the common denominator here is 24. Again, if you want to verify that, start with the largest number here of 12. 8 does not divide 12, unfortunately, but it does divide 24 without too much trouble. So hence our common denominator here being 24. In this case here, we're going to multiply by 3, and we'll multiply the numerator here by 3 as well because we multiplied that denominator. We want to change 12 into 24. We're going to multiply by 2, and we're going to multiply by 2 as well. So putting those two things together here, we're going to get 3 times 3, which is 9, over 24, plus 7 times 2, which is 14, over 24. Then just adding straight across here, oops, should be 9. 9 plus 14 over just the single 24. And so finally, we get our answer here of 23 over 24. And that's going to be our final answer for this problem. All right, any questions about that? Any questions at all? All right. Okay, let's look at another problem here. Okay. All right. So what they talk about is adding fractions vertically. You don't really need to worry about that. Adding fractions vertically is just another way of writing the problem. In all honesty, just write it horizontally. There you go. So 24 is only for the denominator. Yes, that is correct. 24 is the common denominator. We want to be sure that both denominators here are equal to 24. So that's why, as you see here, 24 is just the denominator here that we want to change to before we add those two numerators together to get our final result of 23 over 24. That's right, Hannah. So it helps us, guides us, basically say, hey, we got to multiply by the bottom by 3. Well, I got to multiply the top by 3. There you go. No reducing after multiplying, correct. So do not go backwards. I put that as a note there because I don't want you to go backwards after you multiply. And that's a common mistake. So people say, well, I got to reduce it back down. It's like, well, but then you get right back to where you started. So what was the point? Only, yeah, that's fine. Reduce only at the very end. If you need to, if necessary, if this, after adding and stuff, if that's reducible, then you reduce at the end, but never before. So very good questions there, absolutely. All right. So as I was saying here, we were talking about vertical addition. Now, honestly speaking, like I said, it's another way to write addition with fractions. I'm not a big fan of it because it just makes things tougher than they need to be perfectly honest. So is it really that necessary? No, not really. Just write it horizontally, like you'd write 2/9 plus 1/4. Like this. You could write it on a piece of paper. It's fairly simple. 2/9 plus 1/4. If you just write it like this, it's just makes your life 10 times easier. You're doing the same exact steps. There's no difference in steps, so it's just another way to write the problem. But pretty much all the time I'm going to be writing it just like you see here on the screen, 2/9 plus, yeah, it's just meant to confuse you. So I'm just like, yeah, forget it. I don't want to do confusing things. I don't think you want to do confusing things. So yeah, if you see things written like that, just rewrite it into something you're comfortable with and roll on from there. I don't know why they included that in this chapter. Really, it's really utterly pointless. So, and I don't do pointless things. I don't think you want to do pointless things either. Okay, let's do some subtraction though. Yeah, let's do some subtraction. And which one I want to do? That's pretty good. So 4/5 minus, yeah, 4/5 minus 3/8. Let's do that one. Okay. You ain't wrong, Hannah. Sometimes it's just math is cruel like that. It's like let's put in things that make you not not like other things. Was that 3/8? Check that. Oh, it was 3/8. Okay. All right. Okay, so we have 4/5 minus 3/8. Again, math is cruel. Math can be a cruel mistress. This is true. Yes. He goes, Don't worry though. We're gonna try and make it as easier. Try to make it easier. So that's what we're trying to do. Okay, let's take a look here at this common denominator. Okay, we're gonna do the same thing, same steps. Okay, no difference between add and subtract. Okay, same thing. All right, so that's why I'm not writing steps out because they would be just repeating myself. So let's find the common denominator here between 5 and 8. What's the common denominator here between 5 and 8? Common denominator here between 5 and 8. 40. That's correct. Very good. Again, you can trial and error if you like. 8 doesn't work. 16 doesn't work. 24 doesn't work with 5. 32 doesn't work with 5. But 40 finally does work with 5. 5 divides 40, unlike the other first 4 numbers. Okay. So let's go over this here. Again, the second step here, we're going to multiply each of these fractions to get 40 in their denominators. So how about this first fraction here? What should we multiply by here? I want to change 5 to 40. What do we get? What do we multiply 5 to get 40? 8. That is correct. Of course, balance. Balance says I got to multiply by 8 here as well. Okay, so remember what I do on the denominator, I got to do on the numerator here. Okay, how about 8? What should I multiply 8 by to get 40? 5. Perfect. Again, very nice. So we want to take that 5. We want to multiply that on the numerator as well, right? Again, balance. Always a balance. Okay, and now we're just going to rewrite our fractions after doing this multiplication. So we got 4 times 8, which is 32. We'll subtract that from 3 times 5, which is 15. Now we have it in like fractions. That's exactly what we're looking for. So we're doing 32 minus 15 over 40. Keep that denominator the same. And so if we actually do this out, this will be 17 over 40, which will be our final answer. Okay. Questions about that? Okay, good stuff. All right, what's the next question I want to do here? I want to do, yeah, I'm going to definitely do a question. Yeah, let's do that. Let's do that. Let's do that. Okay. Yes, yes, yes. Let's do that things. All right. All right, let's try a problem for you guys. So again, another practice problem for you guys to try on. We'll give a minute or two. I'm going to make this up here. So we're going to go 1/2 minus, let's go here. We'll go plus, sorry. Let me go plus. Plus 3/5 minus 1/3. Okay. Okay, so we have 1/2 plus 3/5 minus 1/3. And again, now we have 3 denominators here. So we have 2, 3, and 5. So your hint here, again, first, of course, find the common denominator, but between 2, 3, and 5 this time. All right? So we'll give a minute or two, and we'll have you guys give it a try. Go ahead. Hmm. Shouldn't have gotten a negative. Unless you accidentally put minus here instead of plus. I had minus here originally, there should have been a plus here. That may have been what happened. Okay, yeah. Do it with the plus and then tell me what you get there, okay? And we'll take 30 more seconds. Oh, that's pretty close. Okay. All right, so we got a few answers here. That's just fine. Let's go ahead and figure out how we can solve for this one. All right. So first and foremost here, what's the common denominator? Well, the common denominator here for this problem is going to be straight up 30. That's correct. 30 is definitely the common denominator here. Now you could try with 5. You start with 5, and 5 doesn't work with 2 or 3. So you start with 10. 10 works with 2, but not with 3. Go 15. Again, works with 3, not with 2. And you'll keep going up until 30 works with all 3 numbers, just like so. So if we want a common denominator here of 30, let's multiply. We need to multiply the first one here by 15. So 15 here is what we multiply the 2 by to get a denominator of 30. 5, to get a denominator of 30, we need to multiply by 6 on the numerator and denominator here respectively. And 3 here, we need to multiply by 10 on the numerator and denominator here respectively. So let's take a look at what we have here. So multiplying here, we're going to get 15 over 30, and that's fine. Is there meant to have 2 other fractions as subtraction? I'm not sure what you mean by that. It's supposed to have addition. I had plus and then minus, if that's your question there. I'm a little confused. Two. Yeah. Yeah, so I meant to have these 2 addition and then okay, so you add these 2 together and then take whatever that result's going to be and then subtract it from this. Or you can try it doing it this way, Hannah. So like if you once you switch your fractions around, you get 15 over 30 plus 18 over 30, and then that's going to be minus 10 over 30. And then remember, you're just adding and subtracting straight across. That's okay. That happens. It's not a problem. Okay, so we just do 15 plus 18 minus 10. So just like, you would add and subtract, left to right. That's essentially what you can do there is you could put it all together on the numerator there, just like so. So here you get 15 plus 18 is 33, and 33 minus 10 is going to be 23. So that's our final answer here is going to be 23 over 30. Okay. All right, any questions about that? Yeah, absolutely. Let's do another one. That's fine. Okay, let's pick another one. Oh, I didn't want to do that. There we go. All right. The third, this problem? Yeah, we could do another one, three stack problem. Sure. Let me pick 3 more fractions. Okay, I can do that. Oh, sorry. Meant to put 16 there. Yeah, okay. I can do that. Okay, here we go. All right, let's try this, okay? So let's take another minute there, and let's give this problem a try. All right. Hopefully you got a common denominator at least. What's the common denominator for this problem? Okay, good. That's right. The common denominator here is 48. That is correct. So Yvonne got 35 over 48. Okay. Any other answers? All right. Well, let's check to see if it is 35 over 48. Okay. Okay, so our common denominator here is 48. Again, to justify that, we could have start at 16. Okay, now unfortunately 16 doesn't work with 3 or 6. So we go to the next multiple up. We go to 32. And 32 doesn't work with either 3 or 6, so that's kind of too bad, so sad. So we go 48, and 48 does work with 6 and 3, so 48 is our winner. All right, so we need to multiply 6 by something to get 48. What should we multiply 6 by here to get 48? Six times what is 48? Hmm. 6 times 8. Good. That's right. 6 times 8 is 48. Now, of course, if we multiply by 8 on the bottom, we got to do that on the top as well. Okay. All right, 16. We have to multiply 16 by something to get 48. 16 times what is 48? All right, that's right, 3. So we're going to multiply by 3 here. Spot on. And we're going to multiply the times 3 on the top and bottom. That's correct. And 3 times what is equal to 48? Because we want to change that 3 to a 48. 16, that's right. So you get 16 here. All right. So putting that all together, we're going to get 40 over 48, okay, plus 9 times 3 is 27 over 48, minus 2 times 16, which is 32 over 48. So we put that all together, get 40 plus 27 minus 32, all over 48. So if we add and subtract those numbers together, 40 plus 27 is 67. And so here we get 67 minus 32, which is going to be 35 over 38. All right, good beans. 48, sorry. So 35 over 48 is the correct answer. And that's it. That's how we do that problem. Yes, cool story, bro, indeed. All right. Are there any questions about this example here? Okay, good. Okay, so that's as much time as actually we have here for today, so we're actually out of time. So what we're going to be doing here next time is we'll be adding and subtracting with mixed numbers here. I wanted to get that to there today, but yeah, that's okay. We'll talk more about that for next time. We're going to employ these same techniques here into talking about um, adding and subtracting mixed numbers here. So you'll see they want to do vertical stuff. Again, I think it's just going to be more complicated. I'll show you a nice, easier method about how to approach these problems. And, we'll be using the same similar techniques we've always dealt with when it came to mixed numbers, which is changing it into improper fractions. And then we'll go ahead and add or subtract from there. So that's essentially what we'll be doing. And then if we have time, we'll also be talking about order of operations and stuff. So um, yeah, things with fractions and whatnot. You can compare those and do all that stuff. So if we have time, we'll get through that for Thursday. All right. Yep. And then we'll get into decimals after that. Cool beans. Assignments here specifically will be sections. We did section 3.2 and 3.3 here today. All right. This I promise you. All right. Hannah, if you could stick around because I do want to answer your questions. I know we've had a little bit back and forth, but you said you still sounded a little confused there. So I got a little time between classes, so we'll talk about that um, there as well. But before we head out here, are there any questions that any of you have? Yeah, just chill here for a little bit. We'll talk during the break here. So. Any questions anybody else has before we end off here for the day? All right. So if there are no questions here, that's perfectly fine. All right. We'll go ahead and end off here for the day. All right. I want to thank everybody here very much for coming out here today. Okay. Um, you guys are free to go. You guys are free to leave. That's not a problem here. I'm going to keep the stream up here probably throughout the next class as well, as I'm going to help out Hannah for a few questions. But yeah, you guys are free to go, and I will see you guys on Thursday. All right? You guys have a great one, and take care of yourselves. All right. See you later. Have a great one. Bye. All right. Hannah. All right. Let's talk about some of those problems there from that. So let's go here. Come. So I'm going to get to some of these problems here. Did you uh did you get some did you get my emails there, Hannah? Yeah, but did you get my emails, Hannah? That was my question. Like, did you get the emails there? Was I guess the question that I have for you because I tried to explain it via the email. So okay, let's take a look here at this. Okay. Let's see. That was division. Which one? Let's start with division here. You can go with that. Now you can also click on, by the way, you don't have to necessarily click on Skill Builder. You can also click on Question Help and say, view an example or something like that. So you have a lot of other options available to you, Hannah, if you want to get some question help here. But let's talk about actually, let's talk about the first one here. This one's division, so I know we'll come back to this one a little later. I want to go to do the one that you had more questions on, which was that where was it here? Maybe it was 2-8. Okay. Yeah, yeah, yeah. I think that one's better, like this question here, but I'm gonna do a different one. Okay. So let's go with this. Okay. So we have the estimation, and then we have to multiply to find the exact answer. Okay. So let's do this together here, and let's see what we get. Okay. Now, in this instance, we have two numbers here. We have 2 and 2/3, and we got 1 and 7/32. And we're going to multiply those together. Now, in order for us to understand what this will estimate to as our answer, what we're going to look at here is just the fractional part. Okay, so I'm just going to look at 2/3, and I'm just going to look at the 7/32 part, just like so. Now, as I mentioned there in the email, if this fractional part is more than 1/2, we're going to round this number up by 1. If it is less than 1/2, then we're going to round the big number here. We're not going to round the big number. We're going to keep it the same and just basically round down. So 2/3 here, if we take a look here, is actually, if you figure that out, is bigger than 1/2. So in this case here, we're going to round up to 3. All right, so do you understand that part there about why I rounded up to 3? Yeah, so what it's dependent, yeah, you would do half the, so basically it all depends on, it told me that the numerator is half the denominator. So don't worry about what it told you. I'm telling you, you just need to look at the number 1/2, all right? That's it. So think of 1/2 as like 0.5, okay? So as I said, you can check this on the calculator as well. If 2/3 is like, if you check that on the calculator, is 0.67, 6, 7 repeating or whatever, this is still bigger than 0.5. Another way you could do it is exactly like that. If the number on the numerator is more than half of the denominator, then it will work out as well. But if you're not sure about that, you're like, I don't know what that is. Okay, because it may be a complicated number. You can convert it to the decimal on the calculator there, and then you can get a proper estimate to that. So it's a little bit of a shortcut method, but it works. Okay, so we round up to 3 here. So does that make sense? Does that make sense why we rounded this up to 3, at least for this first mixed number? Yeah, because 2/3 is more than 1/2, correct? Because of this. Now we have to answer the question here for this one. Is 7/32? So let's answer this question here. Is 7/32, is 7/32 bigger than 1/2? So this is a yes or no question. Is 7/32 bigger than 1/2? Yes or no? Why don't we check that again? What's 7/32 as a decimal? Try that out first. Okay, good. So that's equal to 0.21. Okay, We don't really care about the rest of that. So is 0.21 bigger than 0.5? Okay. So let's look at the question now. Is 0.21 bigger than 0.5? Yes or no? Okay, think of it in terms of money. 0.21 can think of 21 cents. Is 21 cents more than 50 cents? Think of it, look at it this way. Is 21 cents bigger than 50 cents? No. So the answer here is no. I know you look at it as 5.5, but look at it in terms of money, and you know the answer right away. 0.21 could be 21 cents. That's another way to express 21 cents. 0.5 can represent, say, 50 cents. If the fraction is 50 cents or higher, then you round up. If the fraction is less than 50 cents, then you keep it the same. Think of it that way if that helps. Sometimes money is just the easiest way to kind of um, distinguish the two. So instead of 5, look at it as 50, like 50 cents, because that's what a half represents. A half a dollar is 50 cents. 21 cents is clearly less than 50 cents. So this, because you round down, this would round down to 1. Okay? So in this case here, we actually get 3 times 1, and that's going to be 3 if we do the estimation here. So I'm going to put 3 here for our answer, and you'll see what we get. All right, so we got our estimated answer here, just like so. All right, any questions about that, Hannah, for that first part? Does that make a lot more sense now? Okay, that's good. Yeah, so if look, I'll try any which method here. Money usually helps out a lot because then you're like, oh, 50 cents. Let's take a look. Is it bigger or less than 50 cents? Okay, fine. So, okay. Okay, let's look at the next part here, which is the exact value, right? Because that's the second part. We want to find the exact value to this multiplication problem, okay? Now, for us to find the exact value of this multiplication problem, what we're going to do next here is we're going to go ahead and change both of these numbers into improper fractions. So the first one here is 2 2/3. So 2 2/3 here, again, as an improper fraction, we take 2 times 3. 2 times 3, I think you meant plus 2 there, yeah. I'm pretty sure you meant plus 2. So that's correct, yeah. Yeah. Okay, that's what I thought. Why is 9 plus 10 not 21? You can make it out to be if you like. In math, you could do anything. So that's going to be 8 over 3. So that's what we get here for our first fraction. We have 2 times 3, 6, plus 2 is 8 over 3. So 8 over 3. I can prove to you that 1 plus 1 is 0. Wow. First, first spell correctly, then maybe I'll take you more seriously. All right, anyway. All right, so 1 and 7 over 32 is going to be 1 times 32 plus 7. And put that all over 32. So if we do that here, we get 1 times 32, 32 plus 7. 6. All right, that'll be 39 over 32. Okay, so we're going to multiply those two things together. We're going to have 8 over 3 times 39 over 32. All right, so what we're going to have here specifically is we have 8 over 3 times 39 over 32. Now, the thing is, what we want to do here is reduce stuff down here, okay, Hannah? So we want to be able to find out numbers in common here at the end of the day. So in order for us to do that, as we see here, we have 8 and 32 here. They have a number that you can divide by. We're going to divide by 8 here for this number here, and then this number here. So we got 8 divided by 8, which is 1, and 32 divided by 8, which is 4. We can also do the same for 39 and 3, even though that's a little bit tougher, I'll admit. We're going to divide by 3 here, and we'll divide by 3 here. So we divide by 3 here, and 39 divided by 3 will actually be 13. So here we get 1 times 13 over 1 times 4, which equals 13 over 4. Okay? All right. You with me here so far, Hannah? Yeah. Hannah, you in chat? And I'm gonna make you a mod, Anna. There you go. All right. So here, 13 over 4, we're going to convert over to a mixed number. So 13 over 4 here is going to be, again, how many times is 4 going to 13? 3 times, with a remainder of 1. So 3 and 1/4 here is going to be our final answer. Sure, I'll show you that in chat. There you go. So I'll put 3 and 1/4 here for that. All right. And there we go. If you got a serious question, I'll take it. Okay. It's 13 over 4 as an improper fraction, but you have to change it back to a mixed number. So that's why you get 3 and 1/4. Because 4 goes into 13 3 times with a remainder of 1. So that's where you get the 3 and 1/4 from, Hannah. Good morning, Hisa. How are you? All right, cool. Unfortunately, I don't. I apologize. Robert, good morning, my friend. Good morning. Unfortunately, I don't, Hannah. I gotta start my next class. But if you want to come by during office hours, just email me. email me if you want me to come back. I'll be back after like 12:30 or so. So that's right. Got to learn our math. Morning, Carissa. How are you? Yeah, that's fine. I can just give me a time like after before 11. Oh no, no, after 11. 11 to 1 is when I can be on. That's fine. Cuz I'll have a class at 1 o'clock. So if you want to meet between then, I can be online. That's not a problem. Okay, cool. Thank you. All right. How's everybody doing today? Everybody doing okay? I wanna first apologize, um, because Jonathan was correct. Um, I want to first apologize to you guys because I mentioned this in the first class that I didn't get a chance to grade the test there. I was planning to do it on Sunday, and then my friend took me on an 8 mile hike, and yeah, my back and my legs were all messed up, so really didn't get a chance to. Well, honestly, I didn't really get a chance to get out of bed all that much, and limp to limp slash crawl around all day. 8 miles is pretty good, but when your hamstrings, oh man, let me tell you, your quads and your hamstrings all tighten up like you put a knot in them. Oh, that's brutal. I've had that feeling before, and I'm like, yeah, it takes me like a good few days to just get back. So it's a lot of hiking and stuff, but um, it takes a lot out of you when you're not in shape. So I do apologize about that. So I'll be working on that later today a little bit more. Yeah, even with stretching, I just am plain out of shape. So even even yeah, stretching is exactly right. Stretching really helps, but you're out of shape. It's still not going to help when you don't have the stamina for it. So um, and you got to go up like you know steep steps and whatnot. Yeah, I will admit that. No denying that. Okay. All right. Gotta get going here. All right, running a bit behind here, so let's go ahead and do it right now. Hey. All right, let's leave this. Let's do this. All this gotta go. Actually, not sure why I even did that. All right. Okay. Go. All right. All right. I am. Yes. I actually do teach this class. Surprisingly, even I'm just as shocked some days. All right. In any case, okay, let's get started today. Welcome back to Tuesday. Hopefully, you're a nice weekend. All right. So today, we're going to go over a couple of things here. All right. Today, we're going to talk about something that we talked about here last time, which was talking about the least common multiple. So I kind of want to start with that because what we're going to be focusing on here today is we're going to be focusing on how to add and subtract unlike fractions. Okay, so that's kind of the big deal here going on for today. So, but for us to kind of understand that kind of piece by piece, what we're going to be doing here first is we're going to go ahead and take a look on how we want to kind of attack these problems. But we're going to need the first piece that we're going to need is to kind of remind ourselves how to find the least common multiple. So let's go ahead and talk about those here in this particular circumstance. Okay, so In this case here, yeah, we'll do that. That's fine. All right, so I want to go to section 3.2. We're gonna do a couple problems. All right, where are you? There we go. Okay, so the first problem that I want to do here specifically is this one right here from our last class. Or not from our last class, but from this last section. But we'll talk about how we can apply this to our last class. So it says, write a fraction with an indicated denominator. So it says, write the fraction 2/3 with a denominator of 15. Okay, so let's go ahead and write that in. So here's our fraction here. We have 2/3 and we have some number here over 15. Okay, so that's essentially what we want. I'll go ahead and delete that down. Okay. Now, having this in play, what we want to do is we want to take two keys into account. So let's talk about those two keys here in this case. Okay, so the first one here, the first key that we're going to take into account is if we want to change this 3 into a 15, is we want to find a number to multiply to change the denominator to what we want. Okay, so we want to find a number to multiply to change the denominator to what we want. So whatever number that we want to change to, we're going to want to multiply by that number. And that's correct. The answer is 5. Key number 2 here is we also multiply the numerator by the same number we multiplied the denominator by. So as you see here, if we multiply the denominator here by 5, we multiply the bottom by 5, which is absolutely correct. We multiply the top here by 5 as well. We multiply the numerator by 5. Okay, and then we can just multiply straight across. And as you can see here, we get 10 over 15. Now this is important because if we have 10 over 15, okay, we've been doing examples lately where we reduce these fractions, but that's why I put this note down here. This note says, do not go backwards and reduce again. That is not the purpose of what we're going to be using these fractions for. We're going to be adding or subtracting here specifically, all right, in order to actually do calculations. So we do not want to go backwards and reduce it one more time. All right, so that's not in the cards here for these type of problems, okay? We actually want to keep the 10 over 15 here in this case. Now, one of the other things that is going to be very important and why I stress this example in particular is because of the fact that this is going to highlight one of the most important aspects of all of algebra. If you're going to understand algebra as a subject in general, all right, it always comes down to one very important thing. And that is the big key here of what both keys talk about, and that is the word balance. Once you understand the majority of algebra is just balancing things out, it makes the subject significantly easier. And adding and subtracting, unlike fractions, is definitely a way to show how that balance is going to work out. So you'll see if we have variables, if we have, other, two sides of an equation, whatever the case may be, everything is always typically a balancing act, a zero-sum game, if you will. All right, that's how it usually works here in algebra, or heck, even pre-algebra. It's always a balancing act. So you'll see me use this a lot here in this chapter when it comes to addition and subtraction of fractions. We're always going to be using balance of some form or variety. So even if let's say you go to the next class up, you talk about intermediate algebra, you know what? Hey, balance is still going to be a very big deal. All right, so I want to stress this a lot because it helped me become a better student at a subject that I struggled at when I was doing it out. So um, this helped a lot. Just like, oh, okay, now I'm just kind of making the scales even. That's what I'm trying to do. So a lot of the manipulation really comes down to that one word. Now, the question becomes is, all right, let's take a look here. How do we add or subtract unlike fractions? All right, So let's get to the next, actually, well, let me actually do an example here. Sorry, before I get into that, let me do another example of that last problem. I think that'll be worth it. Let's do this one here really quick. 7 over 6 equals something over 42. So let's do that one. I have a purpose in doing so. So let's go there. Okay. So really quick here, I want to see where everybody kind of is. For everybody here, so what should I multiply 6 by to get 42? What should I multiply 6 by to get 42? So I want to change this, and I want to have a denominator here. All right, Sion and Carissa, Patricia. Okay, good. David. All right, good. All right, all of you say 7. Excellent. All right. Excellent. Nice job, Hughes. All right. So if I multiplied the denominator here by 7, what else should I do? Okay, that's correct. Nice job. Nice job, Patricia. So we're going to multiply that by 7 as well. Spot on. Right. Exactly. So that balance is still going to play a key here. I multiply straight across, right? Multiply that top by 7, and we get straight up 49. So a way to rewrite this fraction would be 49 over 42, and then we could do stuff with it, you know, calculations, whatever. So this is going to be kind of our big key here for today. We're going to repeat this quite a bit in a lot of our examples that we're going to be doing here today. So that's why I kind of stopped and wanted to do one more example here. Just make sure we're all on the same page here when it comes to doing this process. All right. Any questions so far? Nope. All right. Cool beans. All right. Okay. Now let's go to the next section here. And we're going to add and subtract unlike fractions. Now, what are unlike fractions? Unlike fractions are fractions that you either add or subtract here that have different denominators, okay? So if they have different denominators, those are what we call unlike fractions. So as you see here, this example of 2/3 plus 1/9, all right? So what we're going to do here in this case is we're going to talk about how to add or subtract fractions because they do have the same steps here regardless. There's a 3-step process about how to add or subtract fractions, but we're going to go over very slow about how to do each individual step, okay? So let's talk about some of the things. This will have a lot to do with what we talked about last time in terms of like least common multiple, okay? So as you see there on the screen, all right, and see how we can start to piece it together little bit by bit. Okay, so step 1 here. Step 1 says find the common denominator between all of the fractions. Again, the common denominator here will be the least common multiple between all of the denominators. So let's look at that guy there. We have 2 over 3 plus 1 over 9. Okay? All right. So can anybody tell me here, what is the common denominator? We were taking a look at 3 and 9. Okay? Remember, we want to find the least common multiple here between 3 and 9. What's that going to be? What's the common denominator going to be? A common denominator could be 27, that's true, but the smallest said one would be 9. That's correct. So although 27 does work, you know, the thing is that may not be the smallest said one. you may have to reduce later. So that's the thing. 27 would be perfectly acceptable. It's just you'll have to reduce at the end of the problem, which may be a pain to do if you have to have extra numbers floating in there. Okay, so the common denominator here is 9. So we first have to identify that common denominator. Now let's talk about some of those things here. It's just to give you a refresh from last week. All right, so when we talked about the least common multiple, okay, remember, if we're going to find our possible common denominator, I put a couple notes here. First of all, we always start at the largest denominator, okay? So that's always true. We always start at the largest denominator. So between 3 and 9, what should we use? We should use 9 first and see if 3 divides that. And the second note here, the common denominator is always the largest denominator or higher, so we always pick a multiple. We always start at 9, and then we pick 18, and we pick 27, we pick 36. Okay, we see which one of those numbers 3 divides, the smallest said number that 3 divides. Okay, we'll keep going until we find a multiple that does work out. So we're using that same trick we talked about last week. Remember, start with the largest number and go up. All right, so that was a thing we had last time. Is like all of you kind of would have said, if I asked the same question last time, all of you would have said 3. But today, you guys got that right, so that's good. All right. Okay. Let's talk about step number 2. Okay. Step 2. Step 2 says multiply each denominator by a number so we match the common denominator. Multiply the numerator of each respective fraction by each respective number to balance. Okay, so that is step number 2. So we're going to go over this slowly here, and this is the meat and potatoes of the process, most definitely. So we have a common denominator of 9. That's what we have. We want to make sure that we have that common denominator of 9 at the end of the problem. Fair enough. Let's go back to our problem here. So in this case here, let's take a look at this first fraction. We have 2/3. Now we need to multiply 3 by something to get that to equal to 9. That's what we have to do. It says to multiply. So what should we multiply 3 by to get 9? All right. All right, that's correct, right? 3. All right, spot on. Now, what should I do next? If I multiplied by 3 there, what should I do next? Correct. Multiply the numerator by 3. So we talk about balance. Well, guess what? We're going to multiply that 2 by 3 as well. So you'll see me write it out like this. This is kind of like my, kind of workaround here, but that's how I represent. I'm going to multiply by 3 on both the denominator and the numerator. Now, before we move on here, are there any questions so far? So I'm just going to go over this nice and slow here, so that way it's not super confusing. Okay, that's fine. Okay, now let's take a look at 1/9. Now we don't have to do anything to 1/9 here. We don't need to multiply by anything. Why do we not multiply by anything? Well, because we already have 9 in our denominator. So since we already got what we wanted, then there's no point in multiplying it by anything since we got the pieces already put in place. Now, let's take a look at what happens here after we do our multiplication and addition here. So what we have here is we have 2 times 3, which is 6, over 9, and that's fine. And we're going to add that to 1 over 9. Now we did talk about in the first section here of this chapter is that we now have our like fractions. They have the same denominator. So all we're going to do now is either add or subtract the numerators together. Let's take 6 plus 1. But remember, we're going to keep the denominator down here. Okay. So here we get 7 over 9 as our final answer for this problem. So the third step that I put down here is exactly what I've just set out to do. Oops. Is we're going to add or subtract the numerator straight across and keep the denominator the same. So just like you see down here. And then reduce, if necessary, after you add and subtract. So you may need to reduce down. That may be a thing. It just depends on what you get for your final result. But you do that after you do all the adding and subtracting at the end. Okay. And don't forget here, you must have the same denominator for all the fractions before adding or subtracting straight across. Okay, so that's the whole point of finding the common denominator, so we can put it in that same context as we had from before. Okay, any questions about that? All right. Let's try some other problems now, and let's see how we do, okay? Um, okay. So let's try some other problems, and let's do it. Brackets, all right. All right, let's see here. All right. So, okay, yeah, let's pick that one. 3/5 plus 3/10. All right. Okay, so the next one here, we're going to pick 3/5 plus 3 over 10. Don't worry about it. I know it's an accident. You're like, brackets. I'm like, okay. I'm like, yeah, that's okay. I mean, hey, you know, you could have. I mean, you could have done this, and then I would have been like, wow, that's pretty inventive. You know, you could have done this. There you go. And I'd be like, ah, that's cool. I'm glad you spelled out no the hard way. I'm like, that's fine. All is forgiven. I mean, I thought that's what you're going for, so you know, I had to finish the art piece. You know, that's kind of a thing there. Oh man. uh, so funny. All right. Okay. Let's go ahead and do this next problem here. 3/5 plus 3/10. All right. First things first here. Let's find the common denominator. So we gotta look at both denominators here, 5 and 10. What's the common denominator here between 5 and 10? All right. That's correct. The answer indeed is 10. All of you spot on. Very good. Okay. Well, now let's take a look at the first fraction here. We have 5 here in our denominator. What should we multiply by in order to get change 5 to 10? Okay, that's right. I'm gonna pick that too. All right, what else? What else do I got to do now? Okay, very good. So let's multiply the numerator here by 2 as well. Excellent. And we have this other fraction here already with 10, so we should be good to go. So let's go ahead and see what we have. So we have 6 over 10 plus 3 over 10. And so here we get, just add the numerators together, 6 plus 3 over 10, which equals, in our case here, 9 over 10, which is our which is our final answer for that problem. So 9/10, our final result. Okay. Any questions about that? Okay. None from you? Good. We're going to try a practice problem now. Okay, so let's have you guys take a minute or two and try this next problem out. That'll be 5/8 plus 1/3. So we're going to try that one out, and we're going to see what we get. So take a minute or two, and then once you have an answer, go ahead and put it in the chat. All right. So 5/8 plus 1/3. And put the comment denominator. Okay, got 23 over 24. Okay. Good. Okay. Okay. Let's see what else other people came up with. All right, I'll give you one more minute. I got 16 over 24, okay? uh, so did you, for 16 over 24, did you, I can see where you got the 15 part. Did you remember to multiply something with the 1? Make sure you did that. Mm-hmm. Yes, you do. Don't forget, the other fraction also counts. Okay, okay. So let's go ahead. All right. See some of the same answers here. That's good. All right. So let's see if it is indeed 23 over 24. Okay, let's go through this here together. So the common denominator here certainly is 24. Okay, without question. That is true. Oh, that's nice, nice. So with 23 over 24, how does it work? Well, again, you get try 8. 3 doesn't go into 8, so try the next multiple up. Try 16. 3 doesn't go into 16. Try 24. Yes, 3 definitely goes into 24. So, in this case here, 8 we multiply by 3, but of course, balance requires us to multiply that same 3 on the top, on the numerator. 8 here, we're going to multiply 3 by 8 in order to get 24 down there. But of course, balance requires us to also multiply the numerator by 8 as well. Okay, now putting this together, we get 5 times 3, which is 15. We get 24 here on the bottom. And then we'll go plus 8 over 24 is what we'll get for the second fraction. Putting that together, we're going to add the numerators there together, 15 plus 8 straight across, but keep that denominator the same. And then finally, we get our final answer, 15 plus 8, which is 23 over 24, which is definitely the correct answer. So really nice job, everybody. Really good. Great work. Are there any questions about that? Okay, now I'm going to acknowledge one question here really quick that I got from the last class, and maybe just to hopefully clear up any confusion here. As you can see here, both fractions are multiplied by a number, but they're not the same number. So even if I multiplied by 3 for the first fraction on the numerator and denominator, it doesn't mean I multiply by 3 here on the numerator and denominator for the second fraction. So there are two separate entities at the end of the day where we just want to kind of link them up using the common denominator here. Okay, so um, make sure that, I got that question in the first class, so I'm like, okay, let's reduce the amount of confusion there. They can be different numbers as long as you're multiplying the same number on the top and bottom, then you should be okay. All right. Okay, let's try another here. All right. So let's talk about this one here. It says add the following fractions vertically. Now, I'm going to be perfectly honest, okay? This is like one of the most, this is pretty much a pointless question, okay? The reason why is if you add vertically, there's really no point because pretty much what I would like you to solve is I'd like you to solve it, just horizontally like we just did. It's just a rewriting of the problem. So basically, it's kind of pointless to like talk about how to do things vertically because you could just rewrite it horizontally and do the same exact steps that we had from before. So if a homework problem shows you vertical, just rewrite it as a horizontal on a separate sheet of paper. Go through the same 3 steps. You'll find your answer either way. So it's just there to throw you off and make things harder than it needs to be. But yeah, that's why I'm not like super focused on that. It really doesn't serve a purpose. Now let's have you guys take a little bit more of a challenge problem here. All right, so this is going to be a little different from the first class, but a little bit of a challenge problem here since you guys seem to be picking it up. So about 1/8 plus 5/24 plus 7/16. So I'll go ahead and write that down here. All right, so this is a slightly more challenging problem. So I'll let you guys take a minute or two and see what you get here for this particular problem. Again, now you have 3 fractions and 3 denominators to deal with. So let's see how it works out. Once you have an answer, post in chat. Okay, 37 over 48, all right. So one thing I will definitely agree with is 48 there, so very good. We'll see if it's 37. You probably may be right, but we'll see what other answers we get. All right, Sion got 37 48. Oh. Okay. Anybody else want to chime in? All right. That's fine. Let's go ahead and take a look and see what we have here. So 48 is the correct common denominator. You could try 24. Now 8 divides 24, but 16 does not. And you can try 48, and you'll certainly find out that 8 divides 48, 24 certainly divides 48, and 16 actually does also divide 48. So let's go ahead and see what we're working with here. So in order to change 8 here, we're going to multiply by 6. And again, we're going to do that on the numerator and denominator here. For 24, you're going to multiply by 2. Okay, so that's perfectly cool. And then finally 16, we're going to multiply that by 3 in order to get our 48 to work. So putting this all together here, let's see if we get our final result here. So we get 6 over 48 plus 10 over 48 plus 21 over 48. Putting all 3 of those together, that's 6 plus 10 plus 21 over 48. So 6 plus 10, 16, plus 21 is indeed going to be our final answer here of 37 over 48. Great job, everybody. Nice work. All right, great work. Questions about that? No? All right. Well, let's talk about subtraction as well. All right, now, one thing about subtraction is that there's literally no difference between subtraction and addition. They are the same exact 3 steps, okay? You're not doing anything different than what you just did here for these problems. I mean, literally, you just like sit back, relax, and you can just be like, enjoy. It's the same thing. Now, let's try a couple of subtraction problems here, though. Um, again, you're just subtracting say, the numerators here together, reducing as if you see what's necessary here. But let's try something out here. 4/5 minus 3/8 works. Okay, so let's do 4/5 minus 3/8. Okay, so can anybody tell me here what would be the common denominator here between 4/5 and 3/8? What would that be? All right, so the answer here is exactly 40. That's right. Nice job. Everybody's on the ball here today. Dang. Really good. Really, really good. Okay. Can't really argue with that. All right. All right. So here we have 5. All right. We want to change that to 40. What should I multiply by to make 5 a 40? All right. 8. Good. 8 and we skate. This is true. This is true. Although I thought there were... What math is this? This is pre-algebra, Sheriff. There. Got it. All right. How about 8? All right. 5. So to quote Holden's there, 5 and we jive. There you go. All right, so we're going to multiply by 5 there. Very good. So let's go ahead and see what we have once we start putting these together. So we have 4 times 8, 32. 5 times 8, 40. Minus 3 times 5, 15. Over 40. So we get 32 minus 15 over 40. And so we get our final result here, 32 minus 15, which is going to be 17 over 40, which will be our final answer. Nice. Okay, any questions so far? Hopefully these have been pretty straightforward. Well, at least I hope so. Okay. All right. What if the order was reversed, 15 minus 32? Well, in that case, then you would have negative 17. So in actuality, in that case, it's a very fair question though. So in actuality, you have minus 17 if it was 15 minus 32. So order does matter when it comes to subtraction there. One of the things you have to be very careful about when it comes to math. Addition, you're fine. You can reverse stuff around, but subtraction, unfortunately, you can't. Subtraction and division, you can't reverse stuff around and get the same answer. Addition and multiplication, you can without too much trouble. But that's a very fair question, though. All right. Let's have you guys try a problem for yourself, but this time, make up these numbers here. Mm -hmm. All right. Actually, darn it. Yeah, let's put 2. It's fine. All right. So here's our next problem. Okay, so I ramped up the difficulty here a little bit. So let's see if you guys can get this here. We'll take a minute or two, okay, and see if you can get this problem. Once you have an answer, go ahead and put that in chat. Yeah, this one's a little tough. I won't disagree. Remember, start with 25. You got to work your way up. Yep, we got it. Yep, start with 25. Work your way up. 25 is the largest number, Patricia, so. If you're going to find that LCM, yeah, start with 25. It says, all right, see what works, see what doesn't. Does 25 work? 25 doesn't work with 4, so maybe try the next one up. Try 50. Does 4 work with 50? Maybe not. Again, you can keep going. The next one up here, 75. 5 works with that, 25 works with that, but 4 still doesn't work with 75. Next is 100. Yeah. So you'll find out here. Yeah, that's right. So that's why I always point out here that we always start at the largest number and go higher. So if you start at 4, then you're going to be searching for quite a while. And it can be a pain in the butt, and it's actually much harder to do it that way. And yeah, you'll tend to get the wrong result or just be lost. But yeah, that's why you always start at the largest number, because you know it's going to have to be a multiple of the largest number. It has to be. If it isn't, then, well, then you're doing something wrong. So, yeah. Common denominator is 100. So, Sion got 112 over 100, okay? Okay. So I'll give another minute here because that one was a little tough. You got 2 and 47, so 200. Wow, lots of different answers here. So looks like we have 2 and 47 over 100. We got 205 over 100. We got 112 over 100. Okay, so lots of different answers here for this one. Well, this one was designed to be a little bit tough, but that's okay. I have no qualms for you getting this right or wrong. It's all about the learning process. So let's go over each one of these, okay? Now, our common denominator here is definitely 100. Robert, you got 400 over 100. Okay, wow. Lots of different answers. Let's see which one is correct. Okay, let's find out. There's 4 different answers. We're going to need to kind of sort things out here. That's okay. That's okay. Don't worry about it. That's why we're going over this problem here, okay? All right. So we have to figure out 5 times what is equal to 100. Well, turns out, again, that's going to be 20. 5 times 20 is going to equal 100. So we're going to multiply by 20 here on the numerator and denominator here, respectively. For 4, we're going to multiply by 25, because that's how we can get 100 there in the denominator. And we're going to go ahead and do the same thing here as well in this case. All right. Finally, 25 will multiply by 4 on the numerator and denominator here, respectively. Okay, so let's take stock in what we have. All right, so first, we have 9 times 20. And if we do that out, we get 180 over 100. We'll add to that 3 times 25. So 3 times 25 here is 75. So here we have 75 over 100. Now we have 2 times 4, which is 8. So we have 8 over 100. So here, let's see what we get. We're going to go ahead and put all 3 of those numerators together. 180 plus 75 minus 8. And we're going to put that all over 100. So if we add those together here, respectively, we're going to get, yes, so we're going to get here 180 plus 75 minus 8. So 180 plus 75 is 255. Minus 8 is exactly correct. That's 247 over 100. Right. 247 over 100 is correct. And that's correct there. To change it to a mixed number, how many times does 100 go in there? It's 2 with 47 left over. So 2 and 47 over 100 if we have it as a mixed number, or as a improper fraction, it could be 247 over 100. Both answers are acceptable. There you go. All right, and that's how we can do that problem there. So sometimes the denominators there can be rather large, and that can happen, you know. Okay, I hope you're not like pointing at me and like giving me the stink eye. Be like, aha, like, what did I do? Refresh, Robert. Sista, thanks for the follow. Really appreciate you. How did I get the 2? Oh, yes. So ask yourself here, I did let's go over to this here for a second. So that was doing the division here. Okay, so that was like if I said like 247 divided by 100. How many times does 100 go into 247? It goes in twice. And then this is the remainder of 47. So the 2 comes from up here. So 2 and 47 over 100. Oh, okay. Just realized. No, oh my gosh. So that's how we got the two there in that case. Any other questions? No? All right. So I'm gonna make up one more problem here, but this one is you guys' problem. So you guys will try this one here. We're gonna give it a go. So yeah, if you okay, good question, Carissa. So if it's an improper fraction, and let's say the homework problem asks you to write it as a mixed number, then we go ahead and divide. Okay, so just to answer your question there, that's right. That's why if it asks you, hey, I want this answer as a mixed number, then you go ahead and divide and put it into a mixed number like we have over here. Some questions may just ask you for the improper fraction. If it was me personally on a written test, I really wouldn't care which way you wrote it because they both mean the same thing. So yeah, that's for me. I'm like, okay, it is whatever. For the most part, most of the time you use improper fractions after this course anyway. So there's really kind of like, oh, well, there's not a huge point emphasis on it, but again, the homework may do that, so I have to keep that in mind. Let's see. All right, that's fine. All right, let's give this a try here. 3/8 minus 9/10 plus 15 over 4. All right, let's take a couple minutes and give this a try. Again, once you got your answer there, go ahead and put it in the chat. Okay, you got 258 over 80. Okay, so that's one answer there. Are there negative fractions? There can be negative fractions if we get a negative result. Although in this case, I don't expect a negative result at all. But we haven't gone over negative and positive numbers yet, so there can be negative fractions, though, if that's what you're asking in general. Absolutely. Remember, you can move stuff around. Yeah, you remember you can move stuff around, so don't forget about that. You can add and subtract. You have a question about my math lab? Go ahead, Jacob. Do you have to save every question from the homework when you do it, or just the last question? Basically, when you want to stop, hit the save button, or if you just want to be sure, Jacob, just hit the save button, and it's like it'll save those results, so you don't have to redo them again. So if you want to hit like next, and then you want to hit save after that, that's fine. Basically, once you're done, you hit save. That also applies for tests. 99 over 40, 258 over 80. Yeah, so if you're a little paranoid about that, Jacob, just go ahead and save, every so often, so at least you know your progress is being kept. All right. I would totally understand that too, that you put in a lot of work and then suddenly it didn't save because you just exited out of the program. So I can understand that feeling. All right. Well, let's take a good look here at at this, and we'll see what we get. Now, this question here is a bit tough. Okay. Hello. How are you, Adam? All right. Let's look at the common denominator here. Well, some of you had the common denominator of 80, and Robert had the common denominator here. Um, section 3334 for homework. Sections, good, good. Uh, thank you. Thank you. Yes, yes, very much so, my friend, very much so. Section 3.2 and 3.3 here. So the common denominator here specifically is going to be 40. Actually, that is the common denominator here. So if we start at 10, we realize that 8 doesn't go into 10, and neither does 4. 20, 4 works, but not 8. 30, neither 8 or 4 work. But 40, yes, you have a winner. So we're going to have 40 to be our common denominator here. So the first one here, we're going to multiply by 5. Thank you. You're more than welcome to join anytime, Adam. Absolutely. If you have questions, I'll be happy to answer them for you. That's okay. Sometimes that could be a little tough. It's all right. No problem. That's it happens sometimes. You'll notice at the end is if you overshot, you'll have to reduce at the end. So when some people wrote down 258 over 80, then it's like, okay, do you have a possibility of reducing? And then you could say, well, they're both even numbers. So yeah, there's a possibility of reducing, for example. So that's kind of like a good indication about how that happens. I hate when that happens too. All right, so we're going to multiply by 4 here. All right. So let's multiply by 4 for the second fraction. And then we're going to multiply by 10 here for the third fraction. So, like I said, you get 80, that's cool. You just have to make that adjustment there at the end. That's why I put that last step there is reduce if necessary. So always important there. Okay, well let's take a look at what we have here for our 3 fractions. And let's see, what our final result is actually going to be. 3 times 5 is 15, so that one isn't too bad. All right, so this was the toughy part. Here in the middle, 9 times 4 is 36, and we got that over 40. And then we have plus, and we get 150 over 40. So no problem there. I think most people probably got to this part here, but the tough part was the addition and subtraction part maybe. So you had 15 minus 36 plus 150 over 40. Now I know we haven't talked about negative numbers at all, and which is perfectly fine. But another way to actually look at this is to actually swap stuff around. You can actually change the 150 and the minus 36, and you can swap places with them if you like. That's actually okay. So you can actually look at it like this, and we'll actually encounter this later on. So we'll have a 15 plus 150 and then minus 36. So you can do like the left to right kind of addition subtraction there. And then it's just like a lot easier to do. So here we have 15 plus 150 is 165. 165 minus 36 is going to be 129. So 129 over 40 is going to be the improper fraction there. And if you did have to change it to a mixed number, this would be equal to 3 and 9/40. Okay, so you just do the division for that there. The harder part comes with numbers changed with letters. This is true, but if there's one thing you should note about algebra, like we talk about today anyway, I know you weren't here earlier, but that's okay. We always talk about balance, and a balance makes letters not as bad as they seem to be once you understand that essentially you're balancing the equations out to solve for that particular letter. Oh, okay. All right, yeah, plus 150. That's correct, yes. Balance is always the key to all of algebra. So that's what we clue in on all the time when we talk about algebraic equations. Yeah, exactly. And if you understand that you're just playing a zero-sum game a majority of the time, the letters aren't actually as bad as they seem to be. It takes a little time, but once you get used to it, it's actually just the same as what we've done here. Are there any questions about this last example here? No? Oh, that's fine. We're almost done here, Patricia. I promise. I promise you can get to work. So the homework here today, we did finish off section 3.2 and 3.3 here today. So for next time, we're going to go over the next section here. It's just section 3.4, which is going to be talking about adding and subtracting mixed numbers. So adding and subtracting mixed numbers is what's next on the docket here for next time. And then we'll get into a little bit more of applications and stuff in order of operations as well. So that's what's on the agenda there for Thursday. Okay. All right, everybody. All right, everybody. I want to thank you all very much for coming out to the stream here today. Um, Again, thank you so much. You guys make this really fun and exciting. I know it's not the. I know. I know it's. I know math is super dry. Okay, but it's just again, you guys make this a whole lot more enjoyable. I hope you learned something here today. Um, okay, great. Please give me a follow, and I'll see you on Thursday, Adam. All right. You have a question, Anna? Sure. Go ahead. Make sure not to spend 5 hours trying to solo that thing. See you Thursday, Robert. Have a great day, Carissa. Okay. So when factoring out polynomials. Tell your cousin thank you. I'll be happy to help your cousin as well if he or she would like some help. Have a great afternoon, Hisa. You too, my friend. You too. Okay. So 3y minus 21. Okay. Yeah. Anytime, anytime, okay? We cool. So you want to know how to factor this, is that correct, Anna? Okay, so homework today is 3-2 and 3-3. No problem, my dude. You have a good one. So Anna, are you talking about just factoring this particular polynomial? Because it's not too bad. So remember, there's many different types of factoring for polynomials. So there's again, you can factor. Yeah, all right. Is there a certain order? Okay. So let's talk about how this kind of works for a factoring such as for this particular problem. So as you know, there's a lot of different types of factoring. There's factoring, factoring using the AC method. So let's go down the list here. There's factoring using the AC method. There's the rational zeros test, which allows you to factor that way. All right. There's also that. Uh, Another way, of course, is the square root method. Okay, so the square root method is another way to factor. Completing the square is another one. So completing the square is another way to factor. We also have one more type of factoring here, and then that applies to this particular problem here, and that applies to this one here. We'll talk about factoring by grouping. So remember, you have all the particular properties for each one of the types of factoring. So you have to see which one actually fits that particular polynomial. In this case, because we're dealing with just x and y, we can see here that maybe there's something in common between these terms, okay, possibly, then we could try factor by grouping first. Remember, sometimes for certain problems, trial and error may just be the best way of doing things, okay? Is it going to be the way all the time? I mean, no. We may want to see what our narrower choices are, but in this case, you'll see that factor by grouping actually does work here in this particular instance. So here we're going to go ahead and factor out a 3. So here we get y minus 7 here. All right, we bring down the plus sign here. And we see that in this group, we have a y here once again, and we have, in this case here, well, we get x minus 7. So if this was, actually, I should say if this was x and not y, actually, let's change this problem up a little bit so we could make it match. So I'm going to make it match here so it's not like, oh, okay, so. All right, so here what we're going to have is if we factor out an x here, and then we're going to get the same expression here on the right-hand side as well. So we get a y minus 7 here once again. So as you can see here, we have a y minus 7 here. We got a y minus 7 here. So what that'll leave us with is our factoring here, which is 3 plus x and y minus 7. So I know that you're doing associative commutative properties here. Now, I don't commute these. You can commute the terms so long as you keep the signs the same, of course. But I liken it to like saying, can I associate the terms first, and can I get something in common between those terms? So I don't like to move things around using the commutative property. Instead, I like to use the associative property first before I use the commutative property of moving things around, just to see if I can just pair things up together. So that's essentially what I'm doing here in this case. Is there a certain order? Again, I just go from easiest to hardest. So the easier one would be associative. If that doesn't work by grouping, go to commutative to see if you can make it easier that way. That's essentially what you're doing there in this case. Sure. Y is the answer to 28 minus 3x minus 6x squared, 4x minus 7. I would flip them. Oh, okay. Okay. So okay, so yeah, in that case, if you get that type of answer, and I'm not gonna disagree with you here, so let's go over that problem here.